Graph the relation and determine if it is a function. Then state its domain and range. So we got a little bit to do with this one. Let's first just develop a graph of it. Now this one is not a linear equation, so unfortunately I don't have too many shortcuts at my disposal, so I'm just going to end up creating a table of values to help me out. Let's see, let's choose some different values like 4, I got 5, 8, and 13. These values will make it a little bit easier to evaluate this. So if I was to use, say, 4, I would end up with 2 times the square root of 4 minus 4, or 2 times the square root of 0, which is 0. So that's one point I know is on my graph. So at 4, 0. Let's go ahead and put in our next value, and that'd be the 5. So 2 times the square root of 5 minus 4, that'd be 1. Square root of 1 is 1. So I have 2 as this value. So if I plug in a 5, I have 2 as my output. Okay, looking good. Let's try some more. Let's go ahead and put in the 8. So 8 minus 4 would be 4. The square root of 4 is 2. And 2 times 2 is 4. So this shows that when I put in an 8, my output is 4. All right, let's move on. Let's put in, got the wrong point. 1, 2, 3, 4, 5, 6, 7, 8, 4. There we are. Looks like 13 is going to be off my chart, but let's do it anyway, okay? Uh, 13 minus 4 would be a 9. So 2 times the square root of 9. 2 times 3, or 6. So that's another point on our graph. So looking at our points, I might as well start putting them together. Looks like I have a nice little curve right here. Okay, so on to our first question. I was able to graph this, sure, graph the relation, but is it a function or not? Well, does it pass the vertical line test? That's really our question that we should be asking. So if we imagine a vertical line on here, does it cross once, more than once? What's happening? Well, with this vertical line, I can see that no matter where I put it, it's only going to cross this graph in one spot. So I will say yes, it is a function, since it passes the vertical line test. Let's see, now we have to figure out what is its domain and range. So what were all the inputs we could use? What are all the outputs? Well, in making this chart, I can already see some of the inputs I used, but you could potentially use even more than that. Because if we trace back all these values, it also includes all the numbers between the ones we used. So I'm tracing things back to the x-axis, and it looks like I would shade in all of this. So this starts at 4 and continues on from there. So domain would start at 4 and really just go on from there, so 4 to infinity. If I take all of the same values and I start to trace them back to the y-axis, it'll shade in a lot of other values, but it looks like nothing less than 0. So we'd shade in all of that. And now we have our range from 0 up to infinity. All right. So you can see that graphing functions really the same process as just graphing any type of relation. Keep track of your inputs and outputs. If it's a special type of function like a linear function, then use your tools for graphing lines. When it comes to the domain and range, really look at your inputs and outputs by tracing all of the values back, and then showing the intervals or all the numbers that should be included. Thanks for watching Educator.com.